So the next thing I'm going to show you is the axioms of maths busking. Now, as like all good maths busking started with a set of axioms. Does everyone know what axioms are? It's a sort of a bit of a maths word, but it's kind of a set of principles on which we base what we're going to do. So the axioms are where we started from and the kind of the rules that we gave ourselves, and that's what we're going to work within. So the axiom 1, maths busking is busking. And this is very important, because what we're not doing is teaching. We're going to use the techniques of busking to do maths. So we've got to remember that what we're actually doing is street entertainment. So first of all, axiom 1.1, the audience is passive. So a street busker will be outside. He's got a unicycle. He's got some juggling equipment. He's whatever he's going to do. But everyone who walks past isn't really interested. And if he wants them to stop and watch his show and give him some money, he's got to make them look. He's got to make them interested. And this kind of passive audience, maybe slightly hostile audience, is something that mathematicians face. People say, oh, I don't like maths, or I find it difficult. And it's something that we can definitely use. If we have the ability to grab someone like that, we can take use of that and use it for maths. Drop in, drop out, meaning that the crowd isn't necessarily going to be sat there for a whole hour like you would in a maths lesson. So you've got people who would come and watch you and stay at the front and watch you until they get bored and walk off, or you've got people who are just walking past in the distance, and you've got a whole range of people in the crowd. And the people who are walking past in the distance, they might slow down, they might think, oh, what's going on over here? And they'll see someone with maths busking written on their t-shirt who's entertaining a crowd of people. And what they take away from it is just as important. They get the impression that maths maybe isn't just boring and about doing lessons. And number 3, we must be engaging. Anyone who walks past must see us and think, I wonder what this is, I want to see what's going on here. And as part of that, axiom 1.3a, don't worry, it doesn't go any deeper than this, we cannot alienate people. So we can't say, maths terminology. We can't immediately say, oh, we're going to make you do some really hard sums. We can't use words like axioms. So we've got to try and make it very approachable. Axiom 2, maths is the gimmick. So this is another really fundamental point. What we're doing has to be fundamentally maths. We can't just be juggling chainsaws on a unicycle and saying, hey, maths is cool. We've got to use maths to get people's attention. And number 3, maths to take away. Because we're not going to stand there and explain things in the street. We're not going to teach a lesson. So we give people our website, which has got full explanations of all of our tricks and what the maths is behind them, and then people can go home and look at it. Or they can take away the fact that a mathematician entertained them today, and they can tell their friends about that. So, whatever range of things people take away from it, there is something there for them. This screen means that I'm now going to do a trick. So, I'm maths busking again. I'm on the move. Hello, sir, what's your name? Colin, nice to meet you. And your name? Helen, Katie. Okay, well, you two should shake hands with each other as well, so that you know who each other are, okay? So, let's have a maths party. Let's invite lots of people, and let's everyone meet each other. So we've all shaken hands. Sorry. Lenny, nice to meet you. Okay, so if we all shake hands with each other, how many handshakes will that be? I'm sure there's a really easy way to work this out. Let's do some kind of experiment. Okay, so let's get 10 people and see what happens. Would you guys like to join me up on the stage just briefly? Okay, can we get 10 people? Maybe this whole row. And can you find everyone else? How many have we got? Let's get a line going up here. We're going to have a maths party. They're the best kind of parties. And we're going to see how many handshakes we get all together. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Do we need one more? 8, 9. One more person? Okay, this is brilliant. So we've got 10 people. If we can all fit along here, maybe you might need to shuffle to the left a bit. So what we'll do is, we'll do this in a very organized way. So we'll start with Humphrey on the left. And if you'd like to shake hands with all of the rest of the people, and when you get to the other end, remember how many people you've shaken hands with, and do a number of fingers to indicate that, okay? So if you want to go, so that's 1, 2, 3. And now if you'd like to go as well, remember how many people you're shaking hands with. Everyone might have to shuffle left a bit here, or else this could get awkward. So how many people? You've got 9. And how many people was that? Oh, you've already shaken hands with that guy, so you don't need to shake hands again. So you've just got 8,
Okay,
yeah?
okay.
So you've already shaken hands with these 2.
Oh, yes, right.
So you're here, and you've got how many? 7. Okay, keep going. Okay, and you will have 6 there, because you've already shaken hands with those guys. Okay, if you'd like to set off, everyone can shuffle along. So 5 here, yeah. This is very efficient. I'm happy with this. Sometimes this takes forever. Okay. Okay, if you guys would just like to come in here, because if you want to come in at the place where you stop shaking hands, so that we're a bit more organized. So, and you've already shaken hands with everyone else.
Exactly.
So you need to somehow represent 0 using your hands. Excellent. Okay, so now we've got 9, 8, 7, 6, 5, 4, 8? 4. You should be 4. If not, just pretend you were 4. 3, 2, 1, and 0. So this is how many handshakes everyone's done, and we now need to add these all together. Now, before you get your calculator out, as a mathematician, I know a really easy way of doing this. So if Mr. 0, would like to go and stand with Mr. 9 over there, make friends. If number 1 would go and stand with number 8, and we'll pair everyone off. So 2 with 7, 3 with number 6, and number 5 with number 4. And you might want to spread out this way a bit, because it's all getting a bit crowded. So we're now in pairs, and each pair has got how many handshakes? So you've got 4 and 5, you've got 3 and 6, that's 9, 2 and 7, that's 9, 1 and 8, and then 9 and 0. So each pair of people has got 9 handshakes. So if we take half the number of people, which is how many pairs we've got, and multiply that by 1 less than the number of people, which is how many handshakes each group has, then we do 5 times 9 is 45 handshakes altogether. So if we wanted to do 100 people, we'd just need 50 pairs of people with 99 handshakes in each pair, which, of course, 50 times 99 is 4,950. Come on. And you can do this for any number. And this was a method, I think maybe Gauss was involved. One of his teachers asked him to add up all the numbers from 1 to 100 because he was being annoying and he wanted him to keep busy for a while. So he said, there you go. And the teacher thought, oh, he's just discovered a really nice method. So anyway, thank you very much to all of our volunteers. Nice big round of applause. Thank you, Sylvia.